Welcome to another episode of Toy Trains and Arduino. Today we're going to talk about creating a car that senses voltage on your track. We'll use that to discover sections of track that may need attention. Either the wiring isn't right or the track is just dirty. We have our voltage sensing circuit with the ESP32 mounted inside this F3 dummy. And now we're going to use it to compare two sections of track to see if one is better than another. We use the app from my GitHub page to collect voltage readings while stopped. We collect enough readings that we get a nice average, and we store that as a reference. Then we're going to move to another section of track and compare the readings there. Notice while we were moving, the voltage was both a little more variable, but also dropped like 3 volts or so due to the contact of the wheels, possibly, but also the draw of the motor. Without touching the transformer throttle, we have moved to a new location, and that at this new location, we can see that there is a voltage difference between the reference we took and at this location, indicating this segment of track needs some attention. This is a relatively simple circuit, and the schematic is at my GitHub page. You could go there, follow that schematic, and have a circuit up and running in no time. Hi, so we're going to go through the app and how that works, just so you know. You get the app from my GitHub page. You can run it directly onto your Android phone from my GitHub page, or you can make a copy to run from your own location that is HTTPS served. In any event, with that out of the way, the app comes up, and the first thing you'll want to do is you'll want to connect your Bluetooth low energy, and we type that little connect button, and then we select the track voltage car, and it starts collecting voltages right away. And then we can, as we change voltage, we see the number change and the graph change. There's zoom, so we can zoom in on that current value so we can see smaller changes. And there's a couple levels of zoom, so we can zoom in even further if we like. And we can zoom out in the same way. And every time you zoom, it's the graph is centered on the current value. But where the utility of this tool really comes in is to be able to sit in one place and acquire a set of readings that you can compare to another place on the track where you suspect you might be having an issue. So I've acquired that. I can stop the acquisition, and now I have an average. And I can make that average if I'm happy with it. I can make that a reference. And when I do that, we get a delta volt display. So as the voltage changes, we see not only the actual volts, but the difference from the reference we just saved. And if you don't want to compare just current readings, you can compare averages. And all you need to do then is just acquire another average. So I do that, and now I've got two averages, my last average and the average that was collected for the reference. And you see the difference there, 8 volts versus just shy of 6 volts. And that's how all that works. Down at the bottom of the screen, there's the ability to scroll back on the plot. And when I do that, it freezes the live updates. And I could scroll forward. So to get back to the live updates, I type this freeze button, and now we get the live updates again. And then finally, you can download a CSV, and that'll give you a spreadsheet of all the values that were collected since you started running the app. And that's all there is to this. Again, this and all the other software are available on my GitHub page. I hope you enjoyed this episode of Toy Trains and Arduinos. You'll discover, if you venture into making this project, a little bit of an interesting circuit called a clamp. Google clamp, learn about it. You won't have a problem with it once you understand it completely. Well, that's it for us today. Until next time, have fun playing with your toy trains and Arduinos.